Hello. This is a brief example on radio waves. So we'll call this a radio wave example. And before we do that, I want to just remind you that when you use your radio in your car, for example, you turn into either amplitude modulated frequencies, amplitude modulation, and it's often said it's amplitude modulation of a carrier frequency. And what that means is they'll adjust the amplitudes of the waves, and those adjustments will create the sounds you hear in your AM radio. And in general, those frequencies for an AM station go from about 535 to 1605 kilohertz. The other option in your car, unless you've got XM, which is a little bit different, XM would be even a higher frequency than FM, but FM is frequency modulation. And this means that they're modulating the frequency instead of the amplitude, which will end up causing more energetic waves. And that's, of course, FM radio. And FM is from 88 approximately to 108 megahertz. And we could note that in general, electromagnetic waves are produced by oscillating charged particles. So EM waves are produced by oscillating charged particles. And so we're just going to do a quick example, just to solidify all this, a quick example. And so we'll say, let's determine the wavelength of 950 WWJ. So let's determine the wavelength for the radio station. And it'd be 950 AM, and I think they call it WWJ. So as you recall, a wave, we'll draw a picture, even though you kind of could easily get on without drawing a picture. But our wave will look something like that. Remember the three-dimensional wave, and it will have a wavelength, lambda, and the frequency. And we know that the speed of light is always the same, c equals lambda f. We're given the frequency in the problem, 950 kilohertz, and so the wavelength will be equal to c over f, which is, of course, 299,792,458 meters per second divided by our 950 kilohertz. And so the wavelength for WWJ is 315.6 meters. That's a very long wave, isn't it? Whereas, just for funsies, if we were to calculate for 105.1 FM, that would yield a wavelength of approximately 2.85 meters. And so you can see that we're about 100 times shorter wavelength when we go from 950 to 105.1, and we'd have to switch to FM. So FM radio waves are much shorter in wavelength. Have you ever driven in your car and noticed that when you go under a tunnel, if you're listening to AM, oftentimes the AM will break up and you won't be able to hear what's happening on the radio in a tunnel? That's because this wavelength here is is longer than the opening of the tunnel, so the tunnel will block the wave from getting through, and you'll lose your reception of that wave while you're in the tunnel. FM is so much shorter that it usually can get through the opening of the tunnels, and you don't have that same issue. Just something interesting.